So with polynomial multiplication, the first thing that's important is that you understand how the distribution works. Once you understand that, though, we don't always write out all of those steps. That'll take us too long. So once you understand how the multiplication itself works, then what we're actually going to do is going to say, well, in this first example, this 3x is going to distribute to all of the terms in the second polynomial. So I will have 3x times 4x, which is 12x squared. Then distribute to the next term, 3x times positive 1, which is positive 3x. The 3x has now distributed to every term in the second polynomial, so I move on to the next term in the first polynomial. I have the negative 2. It's going to distribute and multiply with the 4x. Negative 2 times 4x is negative 8x. Negative 2 times positive 1 is negative 2. Now I've done my distribution, I've cleared my parentheses, my multiplication is done. My polynomial is not yet simplified because I have like terms. So I also need to combine the like terms. 12x squared plus 3x minus 8x. I have 3, I owe 8, so I would owe 5, negative 5x minus 2. This is the simplified polynomial written in descending order. So I'd suggest pause and try this one on your own. Exactly the same. 2x distributes to both terms. 2x times 3x is 6x squared. 2x times negative 2y is negative 4xy. Moving to the next term, negative 5y times 3x is negative 15yx, xy, commutative property. Negative 5y times negative 2y, negative 5 times negative 2, positive 10y squared. I've cleared the parentheses. I'm not done because I have like terms. I need to clear parentheses and combine like terms for a polynomial to be simplified. 6x squared. I owe 4, I owe 15. So I owe 19. 19 what? 19 xy's. Plus 10y squared. This is in descending order of x's. X to the second, x to the first, no x's, and ascending order of y. No y, y to the first, y to the second. This is simplified. Binomial multiplication you need to be very good, very fast at, and these should be the only steps you write out by the time you're confident with binomial multiplication. Now, when we have multiplication that has significantly more terms, this is a little bit uglier, but we handle it in exactly the same way. Distribute every term, the first term to every term in the second polynomial. X squared times x squared is x to the fourth. X squared times positive 5x is positive 5x cubed. X squared times negative 2 is negative 2x squared. My first term has distributed to each term in the second polynomial. Now I'm going to distribute my second term. That's that negative 3x. Be careful that you're always taking that sign as part of the term. So negative 3x times x squared. And you see here why I'm using different colors for showing that distribution if it helps me. You'll reach a point where you'll do that step mentally, but getting started, drawing those arrows can be very helpful. Problem is if I'm using the same color I'm writing with, those lines get a lot harder to see. Okay. So negative 3x times x squared is negative 3x cubed. Now I could write it just straight along here, but then this is going to get really long and I'll have trouble aligning like terms. So what I'm going to do is put it underneath where I have the like term. x cubed, x cubed. Minus 3x times x squared is minus 3x cubed. If it had been a positive, I'd have a plus sign there because this is one continuous expression. Negative 3x times positive 5x is negative 15 x squared. Negative 3x times negative 2, negative times negative is positive 6x. Had 3 terms in the second polynomial, so each time I distribute I should have 3 terms. Moving on to the last, 2. 2 times x squared, I have plus 2x squared. Again, notice the plus sign. This is a continuation of a thought. 2 times 5x plus 10x. 2 times negative 2 minus 4. I've done my distribution. I still need to combine like terms. X to the 4th, 5 minus 3, plus 2x cubed. Negative 2 positive 2 is 0, so I'm just left with minus 15 x squared, plus 6 plus 10 plus 16x minus 4. In descending order, a polynomial, leading coefficient of 1, degree of 4, constant term of negative 4.